Hi students. Today I am going to uh, discuss about the line integrals. Right? You have studied line integrals in vector integration also. There also you have integrated the vector functions on a curve C, along a curve C. So here also we are going to do the same thing. We are going to define, or we are going to consider a curve in Z plane, that is Z plane. I assume that the function fz is analytic on some region inside the on this plane. So I consider a curve, say I consider a curve C, which starts at P and it ends at Q, right? Then it starts from P and it goes to Q. Obviously, the direction is this. So this is my curve C. Then I'm going to divide this curve PQ into n number of parts. So I said P is equal to P naught. Then this is my P1, this is my P2. So on, I consider the end point as Zn, right? That is Pn, right? Now, the value of Z at P naught is Z naught, at P1 is Z1, at P2 is Z2, so on. At Pn it is Zn. Then, since Fz is analytic, that has to be the condition on Fz. Now, I consider delta Zk to be the difference between Zk minus Zk minus 1. Right. Then I am going to consider, now here I say that Fz is analytic in region R. Right. So I define delta Zk to be Zk minus 1. Then I consider the summation f of Zk times delta Zk, k from 1 to n, right? So, and now I take the limit as n tending to infinity, that is I am going to divide this into more and more number of parts. So if this limit exists, limit n tending to infinity sigma k from 1 to n f of zk delta zk, if this summation exists, then I call that as integration over C fz dz. So why it is called as line integral now? Because I am going to consider the values of z lying on this curve C. Therefore it is line integral, right? The similar kind of thing you have studied in vector integration also. There also we defined line integrals, right? Now properties. Let fz and gz be two analytic functions right, and C be the curve. Then integration over C a times fz plus or minus b times gz dz is equal to integration over a times, that is I take out a is constant, so a times integration over C fz dz plus or minus b times integration over C gz dz. This is the property of first property of the line integral, that is sum of the two integration of sum of two functions is equal to sum of the integration of two functions. This is also called as linearity property. The second one is, if C is made up of two curves C1 and C2, two curves C1 and C2. Then integration over C fz dz is equal to integration over C1 fz dz plus integration over C2 fz dz. So this is the second property. Then the third property. The third property is I am going to define negative of a function, that is a negative of a curve. See, if I consider a curve, it starts from P and goes to Q like this. See, if this is the curve, if I call this as plus C, if I come in the opposite direction, if I start from Q and if I go to P, then it is called as negative of the curve C. So I write that as minus C, right? What the property says is, the third property is integration over minus C fz dz is equal to minus of integration over C fz dz. So this is the third property, right? Now coming to evaluation of integrals. So evaluation of double integrals. It is evaluation of line integrals. Right? Now I am going to consider let fz is equal to u plus I times v. Right? U and v, they are the functions of x and y. U is called as real part of the function, v is called as the imaginary part of the function. Then z is what? It is x plus I times y, the point on xy z plane, the point on xy plane or z plane, it is Argand plane also it is called as, right? Then therefore what will be dz? Dz will be equal to what? Dx plus I times dy, right? Dz is dx plus I times dy. So now integral over C fz dz will be what? Integral over C, instead of fz dz I write that as u plus I times v. U and v, they are the functions of x and y, they are the real valued functions. U is the real part, v is the imaginary part. Instead of dz it is dx plus I times dy, right? So now if I simplify this, so this will be equal to integration over C, I write the real part first, u dx plus v dy minus v dy plus I times, it is u dy minus plus v dx. So this, if I write this into real and imaginary parts, I get this as integration over C u dx minus v dy plus I times integration over C, it is u dy plus v dx, right? So now the line integral in case of complex valued function is transformed into the line integral of real valued functions. Now this is the complex function because of the presence of this iota, that is I. So integration over C u dx minus v dy, this is the line integral in case of real valued functions, plus I times integral over C u dy plus v dx. So this is again the line integral of real valued function. What is the procedure? What I should do? I should find out u is a function of x and y, v is a function of x and y, right? I should either find out the relation between x and y using the third parameter t, then accordingly find out dx dy in terms of dt, then integrate this, or I should find out on the curve C what is the relation between y and x. So accordingly replace the value of y in terms of x, that becomes either function of x only or the function of y only. Then you have to integrate the normal rules or normal procedures of integration. So thus, see, this u dx minus v dy integration, this is a real valued line integral. Similarly, u dy plus v dx integral over c, this is the real valued line integral along the curve C. So once we solve few examples, you will come to know about the evaluation. So the first example I take is the first one. Evaluate integral over C, right? Evaluate integral over C, right? I consider simple function z bar dz, where C is the line joining z is equal to 0 to z is equal to 1 plus I. So what is z is equal to 0? Z is equal to 0 in Cartesian form on xy plane, it is 0, 0, the origin, right? And what is z is equal to 1 plus I? The point is what? It is 1 comma 1. So first let me find out the relation. So now, what is z bar? Z bar fz is equal to what? It is z bar. Solution. Fz is equal to z bar. That means what? It is x minus I times y, because if z is x plus I, right? Z bar will be x minus I times y. So z bar is equal to x minus I times y, right? Then what is z? Z is x plus I times y. Therefore, what will be dz? Dz is dx plus I times dy, right? Dz is dx plus I times dy. Now what is my next step? My next step is I should find out the equation of the curve C. So what is given? The curve C is what? It is the line joining 0, 0 to 1, 1. That is, if I consider the z plane, so this is x axis, this is y axis, z is equal to 0, 0, z is equal to 1, 1. That means the line joining 0, 0 and 1, 1. So this is the required line. So this is origin, this is A. Right? What is the value of A? A is 1, 1. Origin is 0, 0. So the line joining OA, origin at 0, 0, is what? It is simple y is equal to x. So on this OA, the curve C is what? It is OA. OA is what? The line y is equal to x. The line y is equal to x. Correct, no? This line, this is y is equal to x times. So when x is 0, y is 0. When x is 1, y is also 1. So clearly 0, 0, 1, 1. It passes through the line OA. Right? So on the line on OA, therefore on C, what is y? Y is x. Y is x. This implies dy is dx. Correct, no? Dy is dx. Then what is the least value that x takes? Not necessarily the least value, I say. What is the starting point? O is the starting point. What is the x value at O? It is 0. The end point is A. What is the x value at A? So at O, the x value is 0. At A, the end point, x value is 1. Therefore, x varies from 0 to 1 on OA. Right? X varies from 0 to 1 on OA. Now I will evaluate. Therefore, now on my unknowns are evaluated, only I have to write the integral now. Therefore, integral over C fz dz will be equal to integral over OA, it is z bar dz, that is nothing but integral over OA, because x varies from 0 to 1, so 0 to 1, it is x minus I times, because y is equal to x, on OA y is x, so I replace y by x into what is dz. Dz is dx plus I times dy, but dy is dx, so I write this as dx plus I times dx, right? Otherwise dz is dx plus I times dy, but on this line OA, the required curve, dy is dx, therefore it is dx plus I times dx. So this will be what? Integration from 0 to 1, right? Integration from 0 to 1, it is 1 minus I times x into 1 plus I times dx. So this is equal to 1 minus I into 1 plus I is 1 squared minus I squared is minus 1, so 1 plus 1 I get 2, it is 1 plus I into 1 minus I into 0 to 1, it is x dx. So 1 plus I into 1 minus I is 1 squared minus I squared times, it is x squared by 2 from 0 to 1, because x dx integration is x squared by 2. So this is equal to what? It is 1 minus minus 1 times, it is 1 by 2, because x squared by 2 from 0 to 1 is 1 by 2. So 1 minus of minus 1 means 1 plus 1, it is twice 1 by 2, 2 cancel, so I get the value as 1. Therefore, integration over C fz dz is 1. So this is how we evaluate the line integrals. So what is the procedure now? The procedure is, I have to find out along the line C, along the curve C, along the curve C, what is the value of x and y. I have to find out the relation between x and y. Then I should either in terms of y in terms of x, or x in terms of y, or maybe x and y in terms of the third parameter. See here also I would have written y is equal to x. Instead of that I can say x is equal to t, y is equal to t, and t, the least value that t takes is 0, because at O the value of x is 0, also y is 0. The value of t varies from, I can say, 0 to 1. So that also I would have done, right? So dx is dt, dy is dt again. So dx plus I times dy becomes dt plus I times dt. I would have used the parametric equations also here. Let us solve one more problem, right, which eases out, which makes you comfortable in evaluation. So what I say is, evaluate, second example, evaluate integral over C, it is, I take z squared dz, right, integral over C, z squared dz, where C is the curve which joins, that is curve joining O, the origin, to z is equal to 1, and then from z is equal to 1 to z is equal to 1 plus I, right? So the curve is, so C is made up of two parts now. So one is what? So if I draw the curve, So from z is equal to 0 is origin. From z is equal to 0 to z is equal to 1. I call this point as A. So this is z is equal to 1. What? This is z. Z is equal to 1. So what are the coordinates? It is 1, 0. 1, 0 are the coordinates of A. Now from A, 0, 1, it goes to B. That is, I call this as point B, which is equal to z is equal to 1 plus I, or this is same as 1 comma 1. So from initially it goes from OA, then from A it goes to B, right? So from A it goes to B. So it is made up of now two parts, C1 and C2. Therefore the graph of curve is shown in the figure, is as shown in the figure, right? So C consists of C1 plus C2. What is C1? C1 is the line OA, C2 is the line AB. C2 is the line AB. Therefore, integral over C fz dz will be equal to what? Integral over C1 fz dz plus integral over C2 fz dz. Right. Now I have to evaluate integral over C1 fz dz and integral over C2 fz dz. Now what is fz? Now what is fz? Fz is z squared. What is z squared? Z squared is x plus iy whole squared. That is x plus I times y whole squared. So x plus I times y whole squared is what? It is x squared minus y squared plus I times 2xy. Right? I times 2xy. Then what is dz? Dz is dx plus I times dy. Right? Right. Now I have to find out, consider now what I will do is I consider integral over C1 fz dz. So what is C1? C1 is OA. Right? C1 is OA. What is OA? It is x-axis. That is x-axis, that is y is equal to 0. That is y is equal to 0. Y is equal to 0. So this implies dy is equal to 0 because y is constant. If I differentiate, I get 0. So y is 0, dy is 0. Therefore, what is dz now? Dz will be dx plus I times 0, or that is nothing but it is dx. It is dx. So dy is 0, y is 0, dz is dx. Then x varies from what is the starting, what is the x value at O? It is 0. What is x value at A? It is 1. So x varies from 0 to 1. Therefore, integral over C1 fz dz will be equal to what? Integration x from 0 to 1, right? Wherever the fz is what? It is z squared, x squared minus y squared plus I times 2xy. Y is 0, just it is x squared minus 0 squared plus I times 2 into x into 0. It is dx. Because dz is dx, right? So this will be equal to what? Integration from 0 to 1, it is x squared dx. That is nothing but x cubed by 3 from 0 to 1. So the answer is 1 by 3. Therefore this is equal to what? 1 by 3. So integration over C1 fz dz is 1 by 3. I write it here. So integration over C1 fz dz is what? It is 1 by 3. Now I consider integration over C2. What is integration over C2 fz dz? So integration over C2 fz dz will be equal to what? Now I consider C2. What is C2? C2 is nothing but the line AB. The line AB. So what is this line? So x is equal to 1 is the line AB. So x is 1. Then if x is 1, what will be dx? Dx will be 0. Right? Dx will be 0. Then what is the value of y at x is equal, z is equal to a? It is 1, 0. The value is 0. So y varies from the value of y at a is 0 to value of y at b is 1. So y varies from 0 to 1. Therefore, integration over C2 fz dz will be equal to what? Integration y varies from 0 to 1. Then x is 1, so it is 1 minus y square plus I times 2 into 1 into y. X is 1 on AB, right? So into 1. So this into dx is what? 0 plus I times dy. Correct, no? 0 plus I times dy. Therefore, this will be equal to what? I times integration from 0 to 1, because I is constant here. So 1 minus y squared plus I times 2y, it is dy. Right? So if I simplify this, what I get? So if I simplify this will be equal to I times, right? Integration of 1 is y cube by 3, then plus I times it is y squared from 0 to 1. Therefore, this will be equal to what? It is I times 1 minus 1 by 3 plus I times 1. If I simplify this, 1 minus 1 by 3 is 2 by 3. So this is equal to, it is 2 by 3 times I minus, because I squared times 1 gives you minus, I times I into 1 is I squared is minus 1, so minus 1. So therefore, integration on C2 fz dz will be equal to what? It is 2 by 3 I minus 1. Therefore, what is the final value? Integration over C, fz dz will be equal to what? Integration over C1 fz dz plus integration over C2 fz dz. So that will be equal to what? It is 1 by 3 plus 2 by 3 I minus 1. So what is the answer now? Minus 2 by 3 plus I times 2 by 3. So this is the final answer. So this is how we are going to evaluate the line integrals. I hope you followed the procedure to find out the line integral. What you have to do? You have to first draw the line integral, draw the curve, then find out the relation between x and y on that curve, either using the third parameter t or relation between x and y or y and x. Accordingly, which becomes the easier way, you can fix up the limits and you can integrate. I hope you enjoyed my lecture. Thank you. I'll meet you with the lecture on Cauchy's theorem. Thank you.